Hey guys, welcome to my channel. So today we together are going to build a dictionary using binary search tree in C. So since when I learned binary search tree data structure, I thought to implement it in some practical, you know, in some practical way. So the first thing, the first usage that popped up into my mind is of course a dictionary. Okay, and later I thought that you can also make a phone book the same way, the same concept. Okay, so for those who don't know about binary search tree data structure, I'm giving you a brief intro. So binary search tree is a very efficient data structure to search data. Suppose in comparison with linear data structures like linked list, stack queue, array, to search a data you can't skip any node, right? You need to traverse all the nodes to reach a particular data, because you don't know, it might be stored at the end node, maybe you don't know where it is stored. So you can't skip any block or you can't skip any node. But for binary search tree, in the average case you can skip half of the data stored in the nodes. So basically the left child uh, contains data that's less than its parents node, and the right child contains some data that's always greater than the parents node. So this is basically binary search tree. So this video is not about the conceptions of binary search tree. I just gave a basic intro because this project is binary search tree based. So without wasting much time, let's dig into it. Okay, so before I want to let you show, sorry, sorry. So I want to let you show what the final output would look like, so that you have a fair enough idea about what we are going to make. Okay. Okay. So let's run this and see whether my dictionary perfectly works or not. So this is all, I have made this already, but don't worry, in this video we are together gonna make it again. And one thing more, I am, as you can see, I am coding in Atom text editor and I am in an Ubuntu environment. Okay, so yes, so as you can see that there are only three choices. Search, you can search word, you can insert new words into your dictionary, and you can view your dictionary. I mean view all the words that are stored in this dictionary. And one thing that we generally don't do deletion of words from dictionary, so I haven't kept the option to delete. If you wish, you can. You just need to know how to delete some data from a binary search tree, and that's it. So suppose I want to search some data, but of course word not found because my dictionary is empty. And if I want to view, of course empty dictionary because I haven't inserted any any word. So now I want to insert basic. Again I want to insert okay, so I purposely inserted cat before, because you can see that the beginnings are equal CA, but you know T comes after R. So if when I will view the dictionary, car should be above cat. Okay, Like you can see that in your dictionary the word car comes before than cat, right, in a dictionary order. So suppose insert one more like apple and meaning apple's meaning. So okay, let's enter one last one like um, enormous, huge. Okay, so let's view now. So if my dictionary is perfect, then I should be viewing apple, then car, then cat, then enormous. Yep, it is. So my dictionary is perfect. So now let's search words. Say inspire. Of course, word not found because I haven't made the entry of inspire. And let's search some words from the already inserted words like enormous. Fine. Like one more. Fine. So my dictionary is working perfect. So there is no good means by seeing a finished product. I just showed you the output so that you have a fair enough idea about what we are going to make. So we are going to code from the beginning to end step by step, and we are going to have a lot of fun doing this. So let's start. Let me save my dictionary. I just love the names that starts with my. It gives a sense of personalization, I think. Okay, fine. So of course I'm gonna need standard input output library, and again I'm gonna need stdlib because I'll be using exit function and I'll be using dynamic memory allocation. Fine. So let's write the main function first. So in the main function we'll be needing some choices to appear repeatedly until my choice would be equal to 4. So I code in this peculiar way. I think about the output and I code in this way. And then here would be of course a switch case for the choices. So ch is the choice number. Wait, I'm going to declare the variable, don't worry. So case 1 break. Here would be the functions as per the menu, and case 4 exit. So now let's give our user the choices. So first one, as you have seen in the output, would be search. Second one would be insert. Third one would be view, and the fourth one of course quit. You are feel free to quit. Anyway, jokes apart, I hope you are not getting bored because I talk too much. So now, oops, your choice please. And now user will enter his choice and we are gonna store it in our ch variable. Now let's declare the ch variable. So I love to code in this manner because beforehand I don't know that how much variable I'm gonna need. So as I progress in the code and I get the requirement of variables, I keep declaring this. Okay. So now here will be the functions. So of course the first function would be search The second one would be, of course, insert. Okay, I don't know if I'll be requiring any argument to be passed to the functions. So if I require while coding, I will do that. But presently I'm just filling. Okay, so this would be the functions. So now I need to declare the functions, and beforehand I'd like to make the structure for our dictionary using binary search tree. So struct dict for dictionary, and don't forget to put the semicolon. This is a very common mistake that beginners do. Okay, so you can think about node in binary search tree is like, so for this case it would be like a rectangular box with 4 partitions. One for a pointer that would point to the left child of the node, one, since this would be a dictionary, so one, of course, to keep one partition to store the word, one partition to store the meaning, and the last partition to for a pointer to point to the right child of the node, right? Let's do that. And the pointers would be of the same type like the structure, left, right. Okay, and of course I'd be needing character arrays to store word and their meaning. Suppose 10, and suppose for meaning I'm giving 20. Okay, and of course then the root pointer to point to the whole binary search tree, I mean my dictionary, and initially this would be null because initially of course my dictionary would be empty. Fine, my type is ready, but of course I'm not going to write this struct dict every time, so of course I'm going to type def this to a convenient name like dictionary. Okay, fine. So now let's declare the functions. First one would be search. I'm again telling, if while coding the function, if the functions require any argument to be passed, then I would change the declarations accordingly. But for now, let's fill the place. Insert, then view, okay, so and again I'd be needing another function that would be a check function. So what would be the functionality of this function? So basically, since I need to compare strings, so this function would compare string, and of course this function would recur to characters array, and if the first string is greater than the second one, it would require, say, it would require some integer number. So when I code this function, you'd get better. Okay, so I could have used the predefined functions like str cmp or str case cmp like that, but previously those functions have given me some unreliable results, so I thought to implement it on my own. Why to depend on others when you can do it on yourself? So now let's code it out. Firstly, let's code the check function. Check, say these are the arguments. Okay, so I would be needing some for loop because actually okay, let's take an example. Suppose you have opened the dictionary and the first word on that page is dream, but you want to get the meaning of the word, say inspiration. So of course you know that you need to search the later pages because inspiration comes after dream. So in that sense inspiration is greater than dream. So suppose this is dream and this is inspiration, so in that case this would be greater, and accordingly it will return some integer value. So for that reason I need to compare d with I, and since i's ASCII value is greater than d, so I don't need to continue looping for further, because with the first comparison I have got what would be greater. But if the case would be like cat and car, but in that case you need to loop through, because you know the first two letters are similar, ca, the last letter is different, t and r. Okay, so the check function works in this way. So let's do it. I hope you have understood, and if you aren't, then please comment below. I'll try to clarify the doubts. Until and unless both the strings ends, we would continue looping unless there are some break conditions inside. So let's do the first check. If AI is greater than BJ, like you are on the page of dream and you want to get the meaning of apple, so of course you need to search the pages before dream, like, right? So in that case a d is greater than a, so suppose let's take a variable c and let's make c equal to 1, else if suppose the reverse case, and of course if in the first comparison we get a true comparison like two separate letters, then we don't need to loop through further, right? So use break. Same condition for the reverse, ai is less than bj means the second one is greater, like the case of dream and inspiration. Again let's c equal to -1 and put a break. You don't need to compare the later words, but if they are equal, then you do need to compare the later words to know whether the two words are same word or two different words with to some extent same letters, right? Okay, so now let's return. So let's check if c equal to 1, then return 1, else if c equal to -1, then return -1, else return 0. This would be the case when the two words are same. So our check function is ready. So now we can make our search function. Okay. Okay. So what do you expect from a search function from the output you have just seen? Of course it would ask you which word you want to search. Let's write it. Enter the word. And you need to accept the word, so of course you are gonna need a character array. So For that you need to say this would be word. So, and suppose this would have a size of 10, because in the structure the word 2 has a size of 10 bytes. Okay, so now the search function would give you a result whether if the word exists in the dictionary, then it would give you the meaning of the word, and if the word doesn't exist in the dictionary, it would give you word not found, as you have already seen from the previous output, right? So let's code for that. So for that reason I need to loop through the whole binary search tree, and for that reason I would need the help of some pointers, and you know that I can't move the position of the root, so I'll be needing another pointer, and I'm gonna make ptr equal to root, just initializing it, and I'd be needing another indicator type variable because I can't break the loop in between. I need to search the whole, and so I would be needing some indicator type variable. Okay, so let's do. So the loop would terminate only for two conditions. If ptr becomes null, it means that the pointer from the first node, from the root node to the last leaf node, have searched every single node of any of the subtree, because as I've already told that that's the efficiency of binary search tree. At a time you are searching only either left subtree or right subtree, you are ignoring half of the words, right, half of the data. So if the pointer becomes null, then you can pretty much assume that the pointer has searched any subtree, and it hasn't got the data, desired data. And if flag becomes 1, you will get that the data exists. Okay, so let's check. Okay, so guess number 1, the data can be in the right subtree. Okay, so it's like suppose the ptr points to a node, and the node contains the data dream, and you want the meaning of inspiration. So you need to see the later pages right in the dictionary. So same here, you need to go to the right subtree of dream. So let's call check and pass, oops, not check, it's check ptr word and the word entered by the user. If this is 1, means this is inspiration, this is dream, so you need to go to the later pages. Okay, let's go. Now ptr needs to traverse to the right subtree, ptr right. Another condition can be for the left subtree, like the page you have opened contains the word inspiration, but you want to see the meaning of dream, so of course you need to traverse back the previous pages right in the dictionary. Same here, ptr word, and if this returns -1, means this is greater, so of course you need to go to the left subtree, to the left side pages in your dictionary book, right? It's so practical. Else then there can be only left condition is you have found the word. So make flag equal to 1 and give the meaning to the user, printf meaning and ptr meaning, and if once you have found the word, you don't need to look through further. Let's put a break. Fine. So let's give the condition for word not found. So okay, very easy. Flag would be 0 and pointer would be null. Then this would be word not found. This would work for the empty dictionary condition, because in the initial case the root would be null, and since pointer would point to the same node that root is gonna root's pointing, so initially flag is 0 and root would be null. So this condition would work for the initial case when the dictionary would be empty, and all other cases when the word doesn't exist. So our search function is over. Okay, so guys, I don't know if I'm making any silly mistakes, because I'm queen of silly mistakes. So anyway, now let's make the insert function. Let's make it small. Okay, so if you are gonna insert some word into the dictionary, at first you should be aware of whether the word already exists in the dictionary or not, right? So you need to do another search before you insert the word in the dictionary, right? So let me copy the portion of search and then modify it, right? Okay, and let's pass the word from the main function what you are gonna insert. Let's do it before. Okay, so let's make a variable of a pointer of dictionary type that would point to the block of dictionary type, and of course I'm going to use dynamic memory allocation to make a block of our dictionary type. So now one block would be created, and initially the left and right pointer would be null, because of course it would be null because there is a fresh new block of dictionary type. So left would be null and right would be null. So, and now let's insert the word, insert word, it would go into temps. If temp is the rectangular block, then it would go to the word partition, right? And same way, insert the meaning, insert meaning, and it would go into the meaning partition, right? Okay, and now just pass it. And since this function accepts one argument, I need to mention it here. Okay, now let's back to the insert function. Now let's fix it. So we don't need this, and of course we don't need this. So the checking would be between the temp's word and the ptr's word. So this would be the temp word, this would be 2. Okay, good. And now, so as you have seen from the search function, at the end, if the word doesn't exist, okay, let's change the printf function like word exists. Okay, so since the pointer is going to be null at the end if the word doesn't exist, because this will search the whole subtree either left or right depending on what it's searching. So, and we are going to insert the new block or new node at the leaf node position. So before pointer becomes null, we must point to the current leaf node so that we can insert at the left or right child position of that current leaf node. So for that reason I would require another pointer parent to point it, and one simple step would do it. Okay, so before ptr changes, the last node would be pointed so that we can access it for further insertion, right? Okay, so finally now come out of the loop and let's make the proper insertion. Okay, and let's explicitly mention the initial case when our root would be null, means this would be the case of empty dictionary and this would occur only once. So printf empty dictionary, because this would occur only once. Because you can see that if pointer is not null, this is the condition, and initially pointer would be null. So if I don't specify this case explicitly here, this would create a clutter in my program. Okay, and the rest would be in the else block. Yep. So now let's insert. So we have got the parent, I mean the current leaf node, that's the parent, that's the aspiring parent of the node we are going to insert. So we don't know whether the node would be its left child or right child. Let's check it. So if flag equal to 0 means the word doesn't exist, then okay, here I don't need this condition because we don't need this. Okay, because we have initialized flag equal to 0, and since we have given a break condition, so we don't need this condition specified explicitly there. Okay, so let's again call check Simple. If the parent node contains the word dream and we need to insert inspiration, so of course inspiration would go to the right child, to the right subtree. And if the parent node is inspiration and we need to insert dream, then simply it would go to the left child. So if, let's check between per word and temp word. If this is equal to 1, means this would be the left child case. It's and else if parent's word is less than temp's word, then this would be the right child case. It's right. The equal case can't appear here because we have taken the condition flag equal to 0, and here flag has already become 1 if the equal case happens. So apparently my insertion function is done. Okay, so now only one function is left to do, that is the view function. So this view is gonna, if you know how to in-orderly traverse a binary search tree, then this view is gonna do the same. So I'm going to use the recursive approach. So for that reason I need to pass every time I need to call this function recursively from this function itself, and I'll be passing the left and right child. As you know, the in-order traverse works in this way: the left child print the node and the right child. So I'll be passing the left child node and the right child node to the function, so I need to change the declaration, right? So this would be taking an argument of dictionary type. So let's now define the function. Okay, so this is gonna accept one argument. Okay, so again I'm explicitly specifying the empty dictionary case because this would happen only once. Empty dictionary. And the rest would be in the else part. Let's give a termination condition. So first the left, then print the data, we are going to print the word and its meaning. This would be ptr's word, and of course the meaning. And oh shit, what the heck I'm doing. I need to pass it into the function. I told you I'm queen of silly mistakes. Anyway, so my view is done. So apparently we have done the code. Now it's time to run it. Let's have a check before we run it. So everything looks good. Wait. Oh my god. I told you I'm queen of silly mistakes. Shit. This can't be the. Oh my god. Just see, I have given the condition that the first letter would be null and the second letter would be null. Shit. This should be until the character array hits the null character, means until the two strings ends. Shit. I just hope I haven't done any more stupid works. I just hope I haven't. Okay, fine. So let's run it now. And I have made a seriously stupid mistake here. So I just forgot that I was coding insert function instead search function, so forgot to correct it. So if in the initial case when root would be equal to null, means the dictionary would be empty, then the first node we enter, root would directly point to that node, right? So I just hope I haven't done anything else seriously. So let's run it. Okay. Oh, forgot to save. Oops. Okay, so any word, of course, because the dictionary is empty. Okay, let me get some more space. Now, of course, dictionary would be empty, and I'm gonna insert the previous ones, meaning again. Okay, so let's search one by one. Fine. Let's search another one. Good. Another one. Search one word that doesn't exist. Fine. Let's view this all. A CARCT. Fine. So our dictionary is working full and fine. So I hope you enjoyed this video, and I too enjoyed making this program. So don't worry, I'll be sharing the link of this code in the description box. If you're stuck, you can refer that code, but I'd always suggest that don't imitate. I think you have already grasped the concept that what approach I have made to code this. So you code yourself, you make your own approach and do this. So thanks for bearing with me. Happy coding. Bye bye.